Hello, my name is Lucas Galbier, and this presentation is on map projections used for agricultural research. I will be discussing how 3 academic papers make use of various map projections, scales, and coordinate systems to portray different types of data for their readers. The first paper is a study of sustainable agricultural planning in Ethiopia, where suitability of soil was analyzed using a GIS multi-criteria evaluation. This study used 2 maps to help the reader understand the context of the study. The first is a reference map that shows the reader the location of the Galbier catchment in Ethiopia, while the second is a thematic map that shows land areas of various soil types. The reference map is used by the authors to display the local watershed, river, and lake geography of the region, as well as its territorial boundaries. This map uses a nested map to locate the Galbier catchment within Ethiopia, and a legend for geographical reference. This map is a smaller scale map, and uses the universal transverse Mercator system. The thematic map in this study is used by the authors to distinguish soil types by texture, and give the reader a higher resolution view of the territory being studied. While this map is a larger scale map than the first map, it still utilizes the UTM system. The second paper is a study of drought risk for rice cultivation in Ecuador. This study used several maps to help the reader understand the context of the study. However, I will only be discussing 3 of them. The first is a reference map that shows the reader the geography of Ecuador and the location of Babahoyo, while the second and third are thematic maps that capture the climate of the region. Instead of using the UTM system, the reference map in this paper used a longitude and latitude system, indicated by the use of degrees relative to the equator. Although the map uses longitude and latitude, the map projection is still a Mercator. The purpose of this map, like the reference map in the first paper, is to situate the region of the study within the larger context of South America and the regional context of Babahoyo in Ecuador. In contrast, this reference map does not have a legend for territories or geographical features, but instead partitions elevation using color. In this paper's thematic maps, the region of Babahoyo is depicted in isolation of the rest of Ecuador. The maps have a larger scale than the reference map, and elevation is no longer displayed. Instead, these maps show regions within a range of temperature values and precipitation. Like the previous map, these 2 maps use the Mercator projection. In contrast to the previous 2 maps, these thematic maps do not include a coordinate system. The final paper is an overview of global rice cultivation, and it includes 2 thematic maps. The first shows global rice cultivation, while the second shows rice trade and consumption in various countries. Both of the thematic maps in this paper use the Robinson projection. However, the different elements that make up each map help display different types of data. The first map of this paper uses a light color to indicate background information, such as water and land, while darker colors help the reader focus on rice production values. There is a legend indicating scale of production. However, there is no scale for distance. This is because distance is not as important as showing regions of high and low production. The second map in this paper, like the first, uses the Robinson projection. Visually, there are major differences. Color is now used to distinguish countries by their consumption levels, while imports and exports are scaled using a bar graph. Once again, distance is not relevant, so no distance scale is labeled. This concludes our examples of maps used in agricultural research. Thanks for watching, and I hope you enjoyed this quick look at the elements of maps that help scientists display important data for their readers.